If you're still doing LeetCode to prepare for AI engineering roles and interviews, bestie, we gotta talk. In the next 13 minutes, you are going to get the actual 2026 AI engineering roadmap. That's going to skip all the BS, why your traditional learning path is already outdated, and that one skill that separates the hobbyists from the six-figure hires. Hi, I'm Edna, decade in tech, and now I help software engineers and tech leaders to work smarter with AI. So hit that subscribe button so you can level up with me. And as a thank you, here's a picture of my dog, Kaden. Now about that comment on LeetCode. If you're interviewing for companies like Amazon, Google, Meta, all the FANG companies, you might hit some algorithm interviews, even for ML roles. Is it annoying? Absolutely. Is it the reality? Unfortunately, yes. But here is what most miss. For all the large portion of AI engineering roles out there, the startup companies and AI-first companies, they care a lot less about LeetCode problems and if you can solve them in under 20 minutes than if you can build, deploy, and iterate on AI models. More and more hiring managers have been saying this. LeetCode problems and interviews might get you through a round, but projects are proof that you can actually ship. If you're spending 3 hours a day on LeetCode problems and you've never shipped AI model before, we need to rebalance that. You can sprinkling a little bit of algorithm problems in there, but what gets you through the door is actual AI knowledge. Got that? All right, first let's talk about what not to do. A lot of people are still following the advice on learning from 2019. They're being told, get a CS degree, master and learn calculus, linear algebra, and then maybe, just maybe, you can touch a neural network. Look, I'm not saying math doesn't matter. Actually, math was my favorite subject in school. That's why I chose engineering. But if you're waiting until you reverse engineer backpropagation by using the first principles, you're gonna be sitting on the sidelines until 2030, watching others how already shipping AI features. Here's the reality. In 2026, nobody cares about all the theoretical knowledge that you have. What they care about is if you can ship features. They care about who can actually take a very messy business problem, figure out the right tools and coding languages, and ship that to production, that actually works with good quality. Think of it like this. Imagine you want to become a chef. The old way was you spend 4 years learning all about the molecular structure of proteins, fermentation biology, etc., etc. And then maybe after that, you can touch a stove. The new way, you learn knife skills, you understand heat, you follow recipes, you cook. And you learn the chemistry as you go when it's needed for the specific dish and recipe that you're making. AI engineering in 2026 is the same. You're learning by doing, not by preparing to do. And don't just take my word for it. Let me show you something from 2025. This is the 2025 AI engineering report from Amplify Partners. They surveyed about hundreds of engineers actually building AI in production right now. And check this stat out. Our respondents with 10 plus years of software, 45% have 3 years or fewer of AI experience, and about 1 in 10 have less than 1 year. You heard that right. Most of these senior software engineers are all newcomers to AI. It's not anymore about having a decade-long education and knowledge and experience. It's about execution. All right, so what is the actual roadmap? I'm going to break this down for you into 3 phases. And no, each one is not going to take years. Phase 1, get dangerous with Python and AI fundamentals. Notice, I didn't say master. I said just get dangerous. Here's how. Learn Python basics. Loops, functions, data structures, max 2 weeks if you're focused. Learn pandas and NumPy for data manipulation. Let's say max 1 week. And lastly, learn actually and understand what ML is. Things like supervised versus unsupervised training. Max 3 days. And that's it. This is phase 1 for you. Lastly, a month max if you're consistent. But Edna, you're thinking, what about statistics, calculus, linear algebra? You'll learn them when you need them, which is phase 2. Phase 2 is where most people stall out. They keep doing tutorials, they keep doing learning, videos on YouTube, but they never build. Stop watching tutorials. Start breaking things. Here is your phase 2 mission. Pick one real-world problem and solve it, end to end. Here are some examples. Build a recommendation system for something you actually care about: books, movies, restaurants. Create a sentiment analyzer for product reviews. Make an image classifier that solves a specific problem. Identifying plant disease, sorting recycling, whatever. In my case, I used Cursor and ChatGPT to create a support chatbot web version. I created a calendar reminder for folks to take breaks, and also created a website from scratch. The thing I'm trying to get to is that the project does not need to be groundbreaking. It just needs to have these: data collection or finding a data set. Cleaning that messy data, this is where you'll cry a little. It's fine. Training a model. Start with pre-trained models, fine-tune them. Deploying it somewhere people can actually use it. In my case, I used, for example, Google Cloud to try to mess with those tools. I had actually never used Google Cloud before, and it was very easy. This phase, I'd say it will take you 2 to 3 months. That's about how much it took me. And yes, you might hit walls. You might be Googling error messages at 2 a.m., but don't give up. You'll question your life choices, but that's exactly how the real learning happens. I'm a proof. And guess what? In most of my interviews after that, people would always ask me in detail about one of those 3 projects, and it was so much excitement around it. So you see, it's not about theoretical knowledge. It's about actual doing and having experience. Okay, now phase 3, pick your lane and go deep. In 2026, AI engineer is too broad. You need to specialize in one area, at least. LLM engineering. Build with GPT, Claude, Llama, and friends. I used Llama 2 because it was small in size and I could just use my laptop for it. You need to build RAG system on top of those LLMs. And there's MLOps, how to build and deploy and scale and monitor AI models. And lastly, AI agents, building systems that can actually take action, not just predict. Here's a secret nobody tells you. Companies don't need AI generalists. They need people who specialize in one of these areas I mentioned and know it really well. So pick one of the areas where you get most excited about or that there are most job openings in your target market. And then go ahead and build 2-3 projects around it and write about it. Make videos on it. Put it on GitHub. Make it impossible for a recruiter to miss your expertise in those specialized areas. So phase 3, it's going to take you about 2 to 3 months. All right, so let's sum this up. You spend about a month on foundations, about a few months, 2 to 3 months on a real project. And after that, 2 to 3 months on specialized projects. That's about 5 to 7 months of work. It's not 4 years, it's not 2 years, it's half a year, give or take. Now, it might take some people longer, maybe instead of 5 to 7 months, 10 months or a little longer, because life happens. You have a full-time job and other responsibilities. But here's the main point. You do not need to go back to school, and your dream of becoming an AI engineer is not a distant dream. So this is doable, even when you're working full-time. Go for it. And remember, while you're going through it, AI engineering roles are growing across multiple industries, and the salary is premium. You're gonna see about 25% jump in most cases. Okay, I want you to see what this role actually looks like from back last year, 2025. This is from an AI engineer's real day. You see, a lot of this is about understanding business problems, collaborating and communicating well with other teams, being able to debug, test, and iterate. These are all real-world skills that anybody can learn. You can learn, no matter where you're starting from. All right, we covered the roadmap, but I had promised you about that one skill that separates the hobbyists from hires. And it is not what you think. It's not coding, it's not math, it's not even AI specific. Can you guess what it is? It is communication. I know. You're like, Edna, I came here to learn about transformers, but you're telling me about communication? Yes, because here's what's happening in 2026. AI is touching every part of every business. So you can't just be an AI engineer sitting in a corner writing code. You're in meetings with product managers who don't know what a tensor is. You're in meetings with executives who don't understand why a model failed. You're writing technical documentation that the non-technical team members need to understand and use. The engineers who can translate technical concepts into business value, they're the ones who are going to get promoted. They're the ones who are going to get hired. They're the ones who are going to get all the opportunities. Einstein really said it best. If you can't explain it simply, you don't understand it well enough. And in an AI engineering, if you can't explain why your model made a specific decision or what kind of a business impact is going to have a 2% extra accuracy for AI models, I'm sad to say, but you're not going to last long. All right, so here's what you're going to do. Start a blog or a YouTube channel, like me, and explain the concepts you're learning about AI as you're learning them. Comment on LinkedIn posts about AI. Add actual values, don't just flex. In your projects, write a README so well that it's like you're teaching it to a 12-year-old. All right, let's make this concrete. I'm going to walk you through building an AI model in Google Colab, which is completely free. Google Colab is basically like Jupyter Notebook if you use that. No installation, no setup, nothing is needed. It's all on browser and you can just start coding. First, we're importing our tools. Panda for data handling, that's our spreadsheet library. Scikit-Learn for the actual machine learning bits. We're grabbing train.test.split to split our data. And vectorizer to convert text into numbers the model can understand. And multinomial NB, that's our model. It's simple but super effective for text classification. All right, so that was step 1. We're going to move to step 2. We're going to load our data. This is a real data set of SMS messages labeled as spam or ham. Ham just means not spam. It's the normal messages. I'm pulling it directly from a public GitHub mirror of the classic SMS spam collection dataset. Notice we're using pandas to read it as a CSV, but we're specifying its tab separated and giving it column names. See? Each row has a label and a message. It's super straightforward. Okay, step 3, we're going to prepare the data. We're converting ham to 0 and spam to 1 because models work with numbers, not words. Then we're splitting our features, the messages themselves from our target, the labels. Train test split is crucial. We're holding back 20% of our data to test on later. Why? Because we need to see if our model actually works on data it's never seen before. That's the whole point of machine learning. All right, good. We've got roughly 4,400 messages to train on and about 1,100 to test with. Step 4, we're going to transform text to numbers. This is where it gets interesting. Machines cannot read text. They need numbers. TF-IDF is one way to convert words into numeric features. It basically scores how important each word is to each message. We're removing common English stop words like the and because they don't really help us classify anything. And we're limiting to 1,000 features to keep it manageable. Important, we fit the vectorizer on training data only, then use it to transform both training and test data. This prevents data leakage, a super common mistake that makes your model look way better than it actually is. All right, perfect. We've got a matrix ready to go. Now let's go ahead and train the model. We create our classifier and call .fit with our training data. All right, let's move on to making predictions. We test it now. We feed in our test messages. Remember, the model has never seen these before, and see what it predicts. Then we compare those predictions to the actual labels. Look at that, around 95 to 97% accuracy on our very first model is totally normal. Not bad at all. The classification report shows precision and recall. Basically, how good is the model at not mislabeling regular messages as spam, and how good is it at actually catching spam? These metrics matter way more in real world than just raw accuracy. Try it for yourself. And this is the fun part. Let's test it out with our own messages and see how it does. See, it correctly identifies the obvious spam messages and knows the coffee message is totally legit. This is a working AI model you just built in just about 15 minutes of actual work. All right, so is this production ready? No. Would you publish it for a real business without doing more testing and improvements? Probably not. But you are not familiar with the entire workflow for machine learning and training models and using them. That's the whole point of doing projects. If you found this video helpful, I'd really appreciate it if you hit that like button. Also, if you haven't subscribed already, go ahead and click and subscribe. It really helps the channel grow, and it signals YouTube to show this content to others who might find it useful as well. And now I leave you, like I always do, with a joke, because life is too short not to laugh. Why did the AI engineer break up with their neural network? Too many layers of commitment issues. I know. All right, I have a whole playlist that I'm going to link at the end, and make sure to check it out. It's all about different AI topics. I'll see you next.